Welcome to Science Access. In today's class, we're going to be talking about chemical reaction. Introduction to chemical reaction. What is chemical reaction? Chemical reaction is the process where one or more substance called the reactants, these are the reactants, one or more substance called the reactant is converted to one or more different substance called the product. This is the product. So in some cases, it can be one or even more substance, more than one substance called the reactant, are converted to one or more substance called the product. In this case, the reactants are 2 in numbers and the product is 1. So this is chemical reaction. That's what chemical reaction means. Reactant, which can be 1 or more in number, being converted to the product, which can also be 1 or more. Remember, the product is actually different from the reactant and they have different properties. Now, why do elements or atoms carry out chemical reaction? It is simple. They will carry out, atoms actually react with others to attain stability. So, atom or elements react with one another to form products in order to get what? Stability. Hope you're following. Now, let's take a look at this example. Remember, before the atoms actually react, they gain energy and collide with each other, react, gain energy, and the bond between them may be broken in some cases where the products are now what? Formed by rejoining of the reacting particle. Now, let's take a look at this simple example. Now, this is sodium. Sodium have atomic number of 11. Remember, atomic number is the number of protons in an atom. So, number of proton is 11. And remember, proton is positively charged, right? So, number of electron is also 11 because the number of proton is equal to the number of electrons. So, the number of electron is 11. So, remember, the first shell we have atom being made up of the nucleus where the proton is and the neutron, while we have the electrons being distributed in the shell. The first shell is called the K shell. The second shell is the L shell. The third shell is the M. The fourth is the N. Now remember, the first shell only takes 2 electrons. The second shell can take 8. The third shell, 8. The fourth, 8. Now note that. So in this case, we are going to distribute the electron in the shell. The proton is 11. So the first shell will take 2, which is the maximum it can take. Second shell will take 8, which is the maximum it can take. So 2 plus 8 is 10. How many electrons is remaining? 1. So we'll put the last electron in the third shell, which is the M shell. Remember, this M shell have the desire to have 8 electrons. So it is actually hungry for more. Now, let's go to the next element, the chlorine. Chlorine is atomic number 17, which means the number of protons in the nucleus is 17, and the number of electrons in all the shells is 17. So the first 2 electrons will go into the first shell. The second 8 will go into the second shell. So 2 plus 8 is 10. Now the third shell will carry the remaining 7. Remember, we have 17. First 2, the first shell, the K shell. The second is actually 8 electron. 2 plus 8, 10. It's remaining 7. So the 7, you put it in the third shell. Now the third shell can take a maximum of 8. So there's desire for it to get 1. So this atom, sodium and chlorine, react in such a way that this actually desires 8, but it is easier for this to give out the 1 than to accept 7, because this one have 7 in its atomic shell. So it's easier for this to get 1 than to give out 7. So their chemical reaction occur in this way. This is sodium and this is chlorine. This sodium give out that a particular electron in this place to this atom of chlorine, or to this element chlorine. And chlorine now have how many in its atomic shell? 1, 2, 3, 4, 5, 6, 7, 8. Why sodium itself will eventually, since this have been given out, it now has how many shells? 1, 2 shells. So this shell is complete 2, and the second shell has 8. So this atom is stable, and this atom is stable. So why do elements carry out chemical reaction? In order for them to attain stability. Attaining stability means having the number of maximum electrons in their outermost shell. That is the stability we are talking about. Just the way if you get hungry, what happens? You eventually get food and get satisfied. So they want to have the number of maximum electrons in their outermost shell. So in sodium chloride, sodium now have the maximum number of electrons in the outermost shell, and chlorine now has the maximum number of electrons in this outermost shell. Now, note, what is the meaning of this positive sign and this negative sign? Because sodium gives out one electron, it now have a net positive charge. Let me explain this. It has 11 proton and 11 electrons. So we have 11 positive charge and 11 negative charge. If one is removed from the negative charge, we now have 11 positive charge and 10 negative charge. So in mathematics, you now have one surplus or one net positive charge. If you combine the two, you now have one net positive charge. Now, if the electron is gained by this chlorine atom, chlorine now have one excess negative charge because it has 17 proton, which is positive charge, and 17 electron, which is negative charge. So if it gains one, it now have 18 electrons. So in this case, it is actually having a net positive charge or one surplus negative charge. So the force that is holding the sodium and chlorine together is actually the force of attraction between this positive charge and this negative charge. This kind of reaction, this actually called ionic combination or ionic compound. All right, let's take a look at another example. Let's take a look at the second example. This is carbon and this is oxygen. Now, carbon it has an atomic number of 6, which means it has 6 proton in its nucleus and 6 electrons. The first electron, as usual, will take 2, and the second electron, the first shell will take 2, and the second shell will take 4. Remember, it has 6. So, but the second shell actually have the tendency to take maximum of 8, so it actually desire more. For oxygen, atomic number is 8, which means the number of protons is 8, and the number of electrons is also 8. The first shell will take 2, which is the maximum number that it can take, and the second shell will take 6, which is actually remaining. The second shell will take 6, which is actually remaining. All right? So please take note. Now, how do they combine? Take a look at this. This is carbon 4 oxide. This is carbon combining with oxygen for carbon 4 oxide. Now, this oxygen will donate 2 electrons, which is here. Now, notice that the electron of the carbon is represented with star and the cycle. So this carbon, this carbon will donate 2 electrons, such that the outermost shell of this oxygen, take a look at it. How many electrons does it now have? 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen is now stable because it has shared electron with carbon. Now, the second oxygen will do the same. Carbon donates 2 and oxygen donates 2. So we now have 1, 2, 3, 4, 5, 6, 7, 8. It is now stable. Remember, oxygen previously had just 6 electrons in its atmosphere, which is 1, 2, 3, 4, 5, 6. All right. What about the carbon itself? Is it actually stable? Let's count the number of electrons. Remember, the first shell take 2 and the second shell take 8. So we now have 1, 2, 3, 4, 5, 6, 7, 8. So the 3 atoms in this carbon 4 oxide are actually stable. They have attained the maximum number of electrons in their outermost shell and they are now stable. But note this, because they are sharing 2 electrons each, this is actually a double covalent bond. If they are sharing just 1 atom, it's actually they are contributing just 1 electron. In that case, we call it a single covalent bond, but in this case, it's a double covalent bond. You can watch my video on covalent bond to understand this better. Now, you can take this as a simple assignment. This is hydrogen, it has an atomic number of 1. Oxygen has an atomic number of 8. Calcium has an atomic number of 20. Oxygen 8. Write a chemical reaction when hydrogen reacts with oxygen to form water. And also write another chemical reaction when calcium actually reacts with oxygen to form calcium oxide. Take a picture of your answer and send it to the email that is being displayed on the board. Thank you for watching.